Okay, let us now look at the next question. It's a paper 2 question talking about the spanner. Okay, it says a plumber uses a spanner to turn a nut in a clockwise direction. In this case, clockwise direction means that it's pulling in this direction, it's clockwise. Okay, which section of the spanner ABCD requires the smallest force to turn the nut? In this case, in order to turn the nut, it requires a minimum amount of movement. So in this case, for smaller force to occur to produce the same amount of moment formula is force applied times the perpendicular distance. So in order to same amount of force, and I want the smallest force, I want this to go down, which is the smallest, so I need to increase my perpendicular distance. So which portion of the spanner will give me my longest perpendicular distance? So in this case, the answer will be D, okay, which is the section which is furthest away from the, in this case, this is the pivot, okay, the turning point of the spanner. So it has to be the greatest distance here, which is the perpendicular distance D. Okay, that's for A part 1. Let's now move to A part 2. Draw an arrow on the diagram to show the direction of the force applied. So in this case, force has to be either up, down, or left, right. So if I'm pushing it down, it has to be shown with this. So what I will do is I'll put this arrow and I'll label this as A part 2. Okay, this to make sure the examiner know that I'm answering the question for A part 2. Okay, let's move on to question 2b. It says a plumber weighing 800 Newton, which is on the right of the pivot, sits 3 meters from the center of the seesaw. So this is the center point, which is the pivot. How far from the center must his son weighing 600 sit to balance? Okay, keyword is balance, means that it has to be totally horizontal, okay, to balance the seesaw. In this case, we work out from the information that we have first. So in this case, I have the information about the weight of the plumber, which is 800 Newton, and a perpendicular distance of 3 meters from the weight of the plumber to the pivot. So in this case, because it's acting down, so I will have a clockwise movement on the right. So in this case, clockwise movement is equal to force applied 800 times my distance is 3. So I get my answer, which is 2400 Newton, because it's in meters, to Newton meter. So this is my clockwise movement. Okay, what about my corresponding anti-clockwise movement? Okay, because it's the weight is acting down, so I have a anti-clockwise movement. The formula will be 800, and okay, it's not 800. Okay, it is actually in this case actually 600 times unknown distance, which is what I'm trying to find, which is L. So it's equal to 600 L Newton, because it's all in meters, so my unit of measure will be Newton meters. So in order for the balance to occur, it has to meet principle of moments, which is the clockwise moment must be equal to the anti-clockwise moment. So in this case, my final step will be equating these two together. So it will be 600 L equal to 2400. So L is equal to 2400 over 600. So my answer will be 4 meters. Okay, how to check that your answer is correct, that it's 4 meters? Look at the diagram again. Because the weight of the sun is smaller than the weight of the plumber. So in this case, if I have a smaller force, I need to increase my perpendicular distance so that greater than 3 meters, so that it can balance. So 4 meters looks to be a reasonable answer. Okay, so that's all for this question.